Why is porosity important for understanding aquifers? Imagine trying to fill a sponge with water. The sponge's ability to hold water depends on how many tiny holes it has. That's similar to what porosity tells us about underground rocks and sediments. Porosity measures how much empty space is inside a rock or soil. It's the ratio of the volume of these empty spaces to the total volume of the material. This empty space, called pores, can store water. So the more pores a material has, the more water it can hold. Most aquifers are made from sedimentary rocks or loose sediments like sand and gravel. These materials usually have porosities between 10 and 30%. That means 10 to 30% of their total volume can be filled with water. Crystalline rocks like granite or metamorphic rocks, such as schist, tend to have lower porosity because their crystals fit tightly together. Water can only be stored in cracks or fractures in these rocks. Porosity is different from permeability. Permeability tells us how easily water can flow through the pores. For example, clay might have high porosity but low permeability because its tiny pores trap water and block flow. Sand and gravel, on the other hand, have moderate porosity but high permeability, so water moves through them quickly. In groundwater systems, porosity is key because it determines how much water an aquifer can store underground. This affects how much water is available for wells and springs. It also influences how much water an aquifer can recharge from rain or surface water. If an aquifer has high porosity, it can hold more water and last longer when we extract from it. Porosity also impacts how contaminants move through groundwater. If the pores are large and connected, pollutants can spread faster. If the pores are small or disconnected, contaminants move slowly or get trapped. Understanding porosity helps scientists and engineers figure out how much water an aquifer can give us and how sustainable our water use is. It also helps in designing wells and managing groundwater resources effectively. Since sedimentary rocks and loose sediments make up much of the Earth's crust and usually have moderate porosity, they serve as major sources of groundwater. To sum up, porosity controls how much water an underground layer can store. Knowing this property helps us understand water availability, flow, and how to protect our groundwater. It's a fundamental part of water science that guides us in managing this precious resource wisely.